So today starts our 3-section lesson, unit, basically, on scientific notation. So we're going to spend the week learning about scientific notation, and we're also going to start reviewing back through our properties of exponents and what we've been learning about exponents. So today we are estimating quantities. So when you estimate something, are you looking for an exact answer? No. It's just roughly what would the answer be. Okay, so one way to approximate a very large or a very small number is to round the number and write the result as a product of a single digit and a power of 10. So I want you to underline, I know I didn't put the blanks in there, but you need to underline single digit and a power of 10. What does single digit mean? It means that that value must be greater than 1. So x is going to stand for the value that you use. It has to be greater than 1, but less than 10. In order for it to be a single digit, it needs to be greater than 1 and less than 10. Okay? So is 0.7 greater than 1? No. Okay? So it has to be a whole number, but it cannot be greater than 10. Okay? So, and then a power of 10. Does anybody know, what do I mean by powers of 10? What do I mean by that? Anybody know what that is, Connor?
It's multiplied 10 different times. A digit is multiplied 10 different times.
Okay. Definitely has to do with 10. What happens in a place value when you get to 9 and then you try to go to the next number? It carries over, right, to the next place value? So each decimal place or each place value is actually a power of 10. So your ones place, your tens, your hundreds, your thousands, once you get to 10, it rolls over to the next place value, correct? So when we say a power of 10, we're talking place value. In the positive, meaning my ones, tens, hundreds, thousands, and in the decimals, tenths, hundreds, thousands, 10,000s, and so on. All right, are you roughly following along with what I'm saying? Okay, so powers of 10, that's place value. And then single digit means we're looking for a very specific range of values for scientific notation. Okay, so let's look at example 1, the approximate volume of water on Earth. And I'm going to try to put this in perspective for you. It's actually pretty incredible as far as, to me, the proof that God is real and that we have a creator. Let's just look at this. Earth contains about 332, I'm reading that graphic over on the right-hand side, 332,500,000. That doesn't seem like a huge number, right? 332,500,000. But look at the label. Cubic miles of water. How many feet are in a mile, guys? 5,280 feet. Wide. 5,280 feet long, 5,280 feet deep is 1 cubic mile. And Earth has 332 million cubic miles of water. That's a lot of weight. Has anybody ever held like a 10-gallon bucket of water, like a bucket of water that was really heavy? Water's heavy. So think about it, 332,500,000 cubic miles of water. Planet Earth is pretty heavy, isn't it? That's not even including our land mass and the fact that it's not a hollow core, right? Yet we're suspended in space. And we orbit other planets. If you think about that, how incredible that is, something that heavy shouldn't be, we're not falling. We know that because we know that we orbit other planets. But that a gravitational force could be that powerful. Try to wrap your head around that for a sec. Seriously, think about it. To me, things like that, they really emphasize to me that we have a creator. I don't know. That's just me personally. So let's get to math, right? Scientific notation. So we're going to round. With all of these examples today, we're going to take this number And we're going to follow our rounding rules. We want to get to the first digit that is not 0, which in this case is the very first number, 3. And we want to look at the next number. What's the number after 3? 3. So according to our rounding rules, 5 or more, raise the score, 4 or less, let it rest. Yeah, there you go. Okay, how would I round 332 million? Would I round it down to 300 million, or would I round it up to 400 million? 300 million, because the 3 will let it rest. The first 3 will stay the same. So I have approximately 300 million cubic miles of water on planet Earth. So now it wants me to write the result as a product of a single digit. Is this a single digit? No, not even close, but I need it. I need that single digit to be greater than 1 and less than 10. So what number could represent this number? 3. It can't be any other number. It can't be 30 because 30 is not a single digit. 3 times 10, and I need now to figure out my power of 10. Well, remember what we said about powers of 10. It's a place value. So how many place values did I move my decimal from the ones place to the new resting decimal place? How many did it move? 8. It moved 8. You don't count the decimal as 1. You count 1, 2.
You count the egg holders.
Sure. Yeah, the egg holders. Yeah, if you want to do your little arches, 1, 2, 3. Hey, that's fine. That's great. Absolutely. Okay. 3 times, yes, you did. And you will make her very proud. 3 times 10 to the 8th power. Okay. That's it. That's it. Now we're going to talk about a really, really small number. So this you haven't learned, but the concept is still the same. So a very, very large number, we would write it like we did in example 1. But now that we have a very, very small number, like a blood vessel, you probably haven't thought about your blood vessels in this way. It has a diameter of 0.0000924 meters. So round the diameter of the blood vessel. You will go to your first digit that is not 0. So what number is that? 9. So you're still starting at the decimal place and you're working your way to the right until you get to a 9. But how do I know if I need to actually round this 9 up to a 10?
You look at the number behind the 9.
You look at the number behind the 9, which is a 2. So the 2 says that I keep the 9 the same. All right, so my number looks like this when I round it. 0.00009. Now, what happened to the 2, 4? Don't I need my zeros?
No, you don't have to have them.
You don't have to have them when it's a decimal value. You can drop them off. You can write them just in case you just want to visually see that. Okay? So now, how can I write this as a single digit?
I know.
How can I write it, Nick?
9.
It would be 9. Does everybody agree that 9 is greater than 1 and less than 10? So it's got to be a number in there. You can't just say, well, 7 because I feel like 7. Well, no, because you have to keep the value of the number the same. Times 10, and you're still counting place value, okay? 1, 2, 3, 4, 5. You went 5 place values. Please stop. 5 place values to get to your new resting decimal place. But here's the difference, and this is a big difference. What differentiates a very small number and a very large number written in scientific notation? That's a rhetorical, I'm going to tell you. No. Very small numbers in scientific notation must be negative. If I make it positive and someone else reads this, they're going to think that that means 90 million. Okay? But the -5 means, no, this is a very, very small number. So negative exponents in scientific notation mean very, very small numbers. All right, that is so important. When we get into 8.6 tomorrow, that's going to be really important. All right. Okay, so approximating a quantity. What I need to do, all right, it says it tells me the distance from Saturn to Neptune. It's 911,674,960. All right, yeah, that's a mouthful, I know. Okay, all right, so the first thing we want to do, because we are allowed to approximate, is we're gonna round that number. I don't want to have to multiply that number by 1.5. Okay, what would 1.9 billion round to? 2 billion. Okay, so I'm going to round this to 2 billion. Okay, so now I want you, and this is what we just did in the last example, I want you to write this number in scientific notation. Go ahead and do that. I got 2 times 10 to the 9th.
Yay.
Do I get it? Okay, so if that was it, my answer would be A. If that's what the question was asking me, but it's not. This tells me the distance from Saturn to Neptune. It's asking me from the distance from Mercury to Neptune, but I know that it's 1.5 times this distance. So what can I do to that number in order to figure out the distance from Mercury to Neptune?
I do not know.
Okay, let me ask you this. If I told you, let me give you a different scenario. If I told you it was 50 million miles, okay? And then from Saturn to Neptune, and that the distance from Mercury to Neptune was double.
There'd be 100.
It would be 100 million, right? Because you would just double the number. So what do you think you're going to do if it's 1.5 times?
You gotta
Multiply it by 1.
Multiply it by 1.5. So multiply what by 1.5? Multiply 2. Okay? Now, 10 to the power of 9 is going to be the same. So all I'm doing is I'm taking that single digit number and I multiply it by 1.5. You actually don't need to show your work here. There's a real easy way to do this mental math. What is, okay, look here. What is 2 times 1? 2. What is half of 2? 1. What's 2 plus 1?
3.
That's it. Okay? So 1.5 times a number is that number plus half of its value. All right, so I'm going to take a time out here for a second. I'm going to give you a couple more. Okay? What would be, don't blurt it out, what would be 1.5 times 4? Don't blurt it out. Think about it. Based on 1.5 times 4. Okay? Think about it based on what I just said about how to do 1.5 times 2. Anybody know? Micah?
6.
How did you find 6?
Because you multiply 4 times 1 and then you divide that and then add it.
Yep. Okay. Because 1.5 times 4. 1 times 4 is 4. Half of 4 is 2. 2 plus 4 is 6. All right, let's do one more. 1.5 times 8. 1.5 times 8.
So 1/2 times 8.
1.5 times 8. All right, just do mental math. 1.5 times 8. Josh? 12. Because 1 times 8 is 8. Half of 8 is 4. 8 plus 4 is 12. All right, we got to strengthen those mental math skills. Okay, so we know 1.5 times 2 is 3. 3 times 10 to the 9th. Is there an option A, B, C, or D that matches that answer?
C.
C. Okay, so C is my answer. All right, multiple choice.
Why did you?
All right, almost done. Okay, population of the Philippines is about 104,260,000. Population of India is a lot more. 1,282,000,000. So the first thing I want you to do is estimate these two populations. Okay, go ahead and estimate these two populations. We don't want to work with those big numbers, at least for now, because we can just estimate. Whenever it says words like approximately, we know that our answer doesn't have to be exact. Okay, so Philippines is about 100 million and India is about 1 billion. All right, so the next thing I want you to do is write these two populations in scientific notation. All right, go ahead and do that. So we have 1 times 10 to the 8th and 1 times 10 to the 9th. And when we're asked to draw a comparison, that's what I was just telling you guys about. When we're drawing a comparison, how many times greater is one population versus the other? That is division. So I need to divide India, 1 times 10 to the 9th, divided by the Philippines. Something real interesting is happening here.
The
X Y minus
quotient
X2
of powers.
minus plus.
Yes. No, not that. Quotient of powers. You have same base. Look here. You got the same base. So you can subtract your exponents. 1 times 10 to the, what's 9 minus 8? First power. Well, what is 10 to the first power?
1,000.
No, 10 to the first power? 10.
10.
What's 1 times 10? So the population of India is about 10 times greater. About. Now, is it exact? No, because we rounded our numbers. It's approximately. So we really shouldn't have an equal sign. We should have our approximation sign. It's a squiggly equal sign.
Oh, yeah.
Okay? It's about 10 times greater. All right, and that's everything you need to know for 8.5.
Yes.